Okay. So this is also again 1 mark question. If you read the question, a cylindrical rod of diameter 10 mm and length 1 meter is fixed at one end. So one by one will means slowly will go ahead. So if you see the it's like given that cylindrical rod. Okay. Okay. So suppose cylindrical rod is like this. You can see what I am drawing. Can you see? Okay.
Yeah.
So a cylindrical rod of diameter has been given, means diameter has been given, this diameter given, then length also given. Okay. It's fixed at one end. So one end it's fixed like this.
Okay.
Okay. Okay, one end is fixed. Now what's it's saying? The other end is twisted by an angle 10 degree. Okay.
Okay.
So one end is fixed and other end we are twisting, giving a twist, like small rotation. Okay. By angle 10 degree, by applying a torque. Okay. If the maximum shear strain in the rod is this, then P is equal to this. Okay. So I think till now you are clear. Okay. Now it is saying that if the maximum shear strain, okay, there are two kinds of strain. One is normal strain and shear strain. Okay. So no, are you aware that what is normal strain?
Yeah, aware.
So can you tell me what is the normal strain?
Normal strain is strain due to like normal stress, strain created due to normal stress.
Okay.
So the elongation is in the direction of force.
Right. So if you remember this equation, if you
P
remember
by J is equal to 2 by R is equal to G theta by L, I guess.
Okay. So yeah. Okay. So if you remember this, like modulus of elasticity is equal to stress upon strain.
Strain. Yeah.
Right. This is normal strain.
Yes.
This is normal stress, and this is
normal
the
stress.
Modulus of elasticity. Okay. So this is like linear. But if you consider rotational, then you will have the corresponding tail, like shear modulus, shear
G
modulus
is equal to
then tau
shear stress upon
shear strain, gamma.
Yeah.
Okay. This is the like analogy, means analogy with like linear, and this is rotational. Shear stress upon shear strain. Okay. So in this question, we have been given like this is the shear strain. Strain P into 10 to the power minus 3. This value.
Yeah.
Okay. We need to find the P.
Okay.
Okay. So let's see how we do this. Or rotation. We need to remember the torsion equation. So I'll show you the torsion equation. Okay, what is the torsion equation? Because you need to remember this equation, then only you'll be able to do these kind of questions. Okay. So I'm showing you the. See the PDF.
Yeah. Yes.
Okay. So the torsion equation, you need to remember only this. I'll show you what you have to remember. This thing means tau by r shear stress upon radius. Your T by J is equal to G theta upon L. Okay. So one by one I'll explain. Like tau is shear stress. Okay. R is the radius. Radius means like see, if you give like this twisting.
Yeah.
Twisting. Okay. And this radius we need to consider from center.
Yeah, radius of cross section, right?
Yeah, right. Okay. Is equal to T. This is a torque, means this is the applied torque, and this J is polar moment of inertia. Polar are you aware of like moment of inertia?
Yeah.
Area moment of inertia, I think you are aware.
Yeah, area into perpendicular distance from the point of rotation, that is area moment of inertia.
Okay. So actually for like this cylindrical rod,
It is yeah.
Cylindrical rod, the polar moment of inertia is given by pi by 32 d raised to the power 4.
D raised to 4.
Yeah. So you have diameter, and this is the polar moment. This is the formula. You need to remember. Okay. Is equal to G. G, which we were discussing, shear modulus.
Okay.
And this theta is the angle of twist. Of twist. And this is the length of the cylindrical rod. Okay. So now coming back to our question. Question browser, example.
Yeah, Chandra. Yeah.
Okay. So the thing is that you need to use of this shear modulus. Then only you will be able to means get the value of shear strain. Okay. So if you see here, tau max by like they are rearranging the things. Okay. Tau max by G is equal to R theta by L. Okay.
Okay.
And as I told you, like see, I'll again explain, you will understand. Okay. See, G is equal to tau upon gamma or phi, we can say. Means this is the shear strain. This is the shear stress, this is the shear strain, and this is the shear modulus. Similar to like modulus of elasticity. Okay. So if you arrange the thing, like if you bring the G this side, your equation becomes strain. Like this. Right? And the thing is that we need to calculate shear strain. Okay. So that is why we have arranged like this. Okay. Now you got the concept why we have arranged like this, tau by G, because we need shear strain. Okay.
Yeah.
Ajit, Sunil, both of you are clear up to this point?
Yeah, clear.
Okay. Yeah, very good. Very good. Very good. So the thing is that in this question, we need the value of shear strain. And how we get this? By dividing shear stress upon shear modulus. Okay. So if you rearrange this tau by G, you'll get R theta by L. R we are taking this and G we are taking here. Right?
Okay.
So we'll get R theta by L. So your shear strain will be R theta by L. R theta by L.
Yeah.
Okay. So why we are taking R theta by L? Because we have been given diameter, means we can get the radius. Yeah. Okay. We have been given the angle of twist, theta.
Yeah.
We have been given
and
the length
of rod.
So that is why we are rearranging the things like this. Okay. So now we will use this equation to get our solution.
Okay.
Okay. So shear strain they have given like it's P into 10 raised to the power minus 3. They have been given this. Okay. That is why we have written. And remember that this shear strain, this is a strain. Strain has no unit, because if you consider normal dimensionless, right? So if you consider like normal strain, it's like change in length by original length. Both are length, so it's like no unit. That is why there is no unit here. P into 10 to the power minus 3. Okay. So here, let me erase this one so that things become 10 to the power minus 3 as it has been given in the question. Okay. Now is equal to our radius. Radius is like 5 mm. Diameter is 10 mm. So what would be the radius?
5
mm.
Yeah.
Okay. So let's like we'll have like we suppose
Data.
Yeah. Okay. You can take either in meter or mm also. Let's like we'll consider like meter. Okay. SI. Normally you consider SI unit. Okay. Meter. So that everything will be in standard. Okay. So our radius is 5 mm. 5 mm means 5 into 10 to the power minus 3 meter, right?
Yeah.
5 into 10 raised to the power minus 3 meter.
3.
Right. R we have. Now, what is the value of theta? Theta is 10 degree.
Yeah,
but
we
in
convert
standard,
it into radian.
Right. Very good. So in SI unit, we deal with radian. So you need to convert degree into radian. So how we convert? Like pi
by 180.
Yeah, you can remember that pi radian is equal
Pi
to
d-
180
180
degree.
degree.
Okay,
Yeah.
so 10 degree will be equal to pi by 180.
180.
Okay, so degree will cancel and you will have radian. So this is the way to convert 10 into pi into, okay. So I'll again write here to make the things here clear. Okay. So the radius we have written. Now we'll write the angle of twist, theta. Theta is 10 degree. So in radian, it will be 10 into pi by 180.
Pi by 180.
Right.
Yeah.
Very good. Pi by 180.
And then divided by 1 meter.
1 meter.
Yeah.
We are considering meter. In this, here they have considered mm. From mm top, from mm bottom, mm cancel, and you will have like dimension because the radian is a like angle. Okay.
Yeah.
Okay. So if you bring this 10 to the power here, 1000 you will get. Okay. It's one and the same thing. Okay.
Yes.
So now if you like solve this, if you have pen and notebook, you can solve. I will also solve so that we can have like practice. Okay. If you solve this, just check whether you will get the value of P as this. Okay. You can solve. I will also solve. Okay. If you have, because in exam you can bring calculator also. So if you have calculator, you can use that also.
Actually, I have. Okay.
1000 below.
Okay. So I'll repeat 1000 below. Why? Actually, the thing is that radius is 5 mm, right?
Yeah.
5 mm. And what is the length? Length they have given 1 meter. Okay.
Yeah.
So if you are taking here as mm, see they have written like 5. Okay. So if you are taking, understood, very good. So that mm and mm will cancel, so that you will have like no dimension, because phi has no dimension. Okay. So LHS, if LHS there is no dimension, then RHS will also be dimensionless.
Yeah, fine. Yeah.
Okay. So if you like P into 10 to the power minus 3, you will get is equal to, if I am seeing the calculator, it's like 8.72 into 10 to the power, like 8.7 into 10 to the power minus 4. So if you so if you find,
and other side we have 10 raised to minus 3, right? So that if you divide,
and remember, you need to calculate the value of P only, not this 10 to the power.
P into 10 raised to minus 8.
Yeah. So in question only P, value of P is asked. So okay, 0.87 will come. Point for me, and I have done the calculation. 0.87 is coming. Okay. So I think both of you are clear with this question.
Yeah, clear.
Yeah. So again,